I hesitated a little bit on hitting the live button. I don't know why, but what we're gonna do is turn on the music. Okay, close that. Come over here. This is the thumbnail I made. Just a couple of layers. um, I made this part right here metallic so that it reflects the light that I have like pointing at one of those eyes, and I think it looks really cool. There's also this light sun over here that I have facing towards it so that it lights up that ring of the space wallpaper, and I used it as a texture. I also took the inner ring of this and I just did a little bit of a a rotate like that, and I made it warp around. So I think that was pretty cool. So I'm learning more. I'm learning more stuff. I'm learning more stuff. Watched a Markiplier video a while ago, so I decided to put that badge right there. So I thought it was pretty cool. But anyway, I'm going to Control save the Blender file, and then I'm going to do new general, and then I'm going to have that right there. So what I'll do is I'll probably shrink this over to here and have that be like that. Oof. Oof. It's hard to have everything fitted in a way that makes it so we can have the manual and Blender open at the same time. But anyway, we did the bisect tool area, so now it's knife project. Knife project. Knife project. Project? Who knows? I'm gonna say project. Knife project. Projects the outline of one or more cookie cutter objects into the edited object and creates new edges there. The cutter objects must be curves or non-manifold meshes. Example, flat shapes, loose edges. Select non-manifold will highlight the edges, the cutting edges of the mesh objects. Projection is done along the viewing direction. Usage. Okay, so I'm gonna do Shift A, do text. So I'm gonna add text, do 90 degrees, and then G, Y, do that, G, X, do it like that, shrink it again, and then I'm going to be like that. Okay, so I'm going to select the object, select the objects that should receive the cut, and switch into edit mode. 2, select the object that... Oh, wait, hold on. I need to convert that into a mesh. Tab. In edit mode. Select the objects that should perform the cut by clicking them with Control left mouse button. In 3D viewport. Click Mesh Knife Project in the menu. If Blender switches back to object mode when selecting the cutting objects, make sure Edit Lock Object Modes is checked in the top bar. Look at that! Look at that! We got text. Ooh, actually, hold on. There we go. We got it. Wait, does it need to be a mesh in order to do that? Not mesh. Okay, so edit mode. Control Mesh Knife Project. Oh, cool. So it doesn't need to be... Oh yeah. Ooh. wait a minute. Wait a minute. Does that mean that I could... Hold on. Where's my ASCII art? Where's my ASCII art? Lifeboat. Jaded Skull TXT. Control C. Control V. Needs to be a different font. True type. Deja vu. Deja vu mono sans. Sans mono. Yeah, sans mono book. Rotate Z90. V. Okay. Okay. Edit mode. Control. Click. Mesh. Right click what I'm going to be doing. Mesh. Knife project. Uh-oh. Is this Yes. Yes. Excellent. Excellent. That's beautiful. That's absolutely beautiful. I love this. I love this so much. So much. Oh. Oh. 32,484 triangles. Uh-oh. Uh-oh, that's a lot of triangles. Okay, this is fun. What's, so that's knife project. Oh. Okay, known limitations. When cutting multiple meshes in edit mode at once, geometry from these meshes conclude does not include separate mesh objects behind them. Okay. Knife topology tool. Mode. Edit mode. Toolbar knife. Shortcut K. Okay. First, select the tool in the toolbar, or press K. K. The cursor will change into a scalpel to indicate it's active. Yes. Look at that. Click left mouse button to place where you want to start cutting. This can be anywhere on an existing vertex, edge, or face. Or even outside of a mesh. Move your mouse to the next location. You'll see a yellow line indicating the new edges that will be created, and aqua dots indicating the new vertices. Click left mouse button to confirm and start the next cut. Next cutting segment. Once you're done, press spacebar or return to apply the cuts. Alternatively, press escape to cancel. And that's what I did last time when I was doing the... That's cool. That's cool. That's super fun. Coriolan Overture. Ludwig van Beethoven. Cool. And let's just rotate. What should I be doing? Fresh cube. Okay. There's that. Tool settings. These settings are only available when using the tool from the toolbar, not when pressing play. They can be found in the tool tab of the properties editor, and of the sidebar. Cool. Cool. So when you want to use bisect, you gotta, okay, hold on. When you want to use bisect, you gotta click and hold this left button and then choose between knife or bisect. And I assume it's, yeah, offset, edge loop cut, extrude manifold, extrude individuals, extrude long normals, extrude to cursor, add cube. Oh, okay. Edge slide, vertex slide, smooth randomize, shear to sphere. Shrink, flatten, push, pull. Okay. Okay. Cool. We're gonna do a new general. Don't save. tool settings. These settings are available when using the tool from the toolbar, not when pressing K. They can be found in the Tool tab of the Properties Editor and of the sidebar. Okay, so if I oh, okay. So that's how you select the scale key. Edge slide. Shift K. Report error. Select case required. So S measure midpoint step. Oh, that's where mid. Okay, you hold shift for midpoint snap. Okay. Hmm. Cool. So what we got here? X-ray show cutting path even if it's secluded by geometry. Measurements. The measurements to show along the cutting path distance, angles, or both. Only angles, both distance and angle. Angle snapping. Whether to constrain the cutting lines to multiple of the sharp increment angle. None, no snapping. Screen, snap in screen space, the viewing plane. Relative, snap in a plane on the geometry relative to an adjacent edge or cutting line. Angle snapping, whether to constrain the cutting lines to multiple of the snap increment angles. None, no snapping. Screen, snap in screen space, the viewing plane. Relative, snap in a plane on the geometry relative to an adjacent edge or cutting line. Relative snapping at 90 degrees, Blender highlights the reference edge in red and shows the snapping direction in white. Doing a few more cuts in a plane. Okay. Snap increment, the angle to use for angle snapping. Okay. Okay. So, screen. Shift G area. I. E. Shift Control F along normals. Cool. Wonderful. Closed loop double click adds a cutting point at the cursor just like on a single click, and then it connects it to the first point in the current path. Okay, hold on. Closed loop adds a cutting point at the cursor just like one single clicking. Then it connects it to the first point in the current path. Perfect. Merge at center. Shift G area. And I. Control F along normals. Shift G, length. What does this look like after subdividing? Looks pretty cool to me. It's very hot. What temperature is it? What's the temperature? Oh! It's 80 degrees in my apartment, apparently. I'm not doing air conditioning. I'm not doing air conditioning. No. I'm European style. That's what I am. I don't have the money for air conditioning. What do you mean? Yeah, I could go to my storage units and I could get the air conditioners from my storage unit and then set them up in here. But I'm not going to pay for those utilities. Like, what do you... And, like, what exactly is going to really happen in my apartment? This is such a cheap place that's so drafty and there's cracks in every single window and door. You can fit a stack of quarters through the front door. It's like, why even bother? It's ridiculous. I'm not bothering. I'm not going to bother. Not gonna bother. That's just the case. Confirm the spacebar and return. Cancel with the X. Escape. Undo with Control Z. Midpoint snap to Shift. Ignore snap Control. Cut through C. Oh, okay. Hold on. Okay. Cut through space. Ace. I'll figure that out later. I'm not sure how cut through works. Okay, X. I angle constraint. Press. Okay. Okay. A. By default, the snapping is done in the screen plane. Press a second time to snap in a plane on the geometry relative to an automatically chosen edge cutting line. You can press R to select a different reference line. I don't think that that's doing anything I can understand. Convex hull. Oof. Convex hull creates a convex hull surrounding the selected vertices. Original edges and faces that lie on this hull may be reused. This operator can also serve as an alternative for bridge edge loop. Input mesh, loose vertices, and convex hull result for both. Mesh, convex hull. Well, that's an exact match. Except mirrored. Okay. Shift S to select it. Okay. Okay. Big brain idea. Big brain idea. Shift A, mesh, monkey, mirror, Y global. G, Y. The selection, then edge, shift S, cursor to selected, then it's that, cut origin to 3D cursor. Rotate. How do I get it to hinge? I can't get it to hinge, can I? Okay, I was just messing around. Okay. Can't really do something like that quite yet. Can't really do something like that. It will be a fun idea eventually, though. Okay. Options. Delete unused. Removes unused edges and faces that were selected but not used as part of the hull. Use existing faces. Are possible using faces that lie on the hull. This allows the hull to contain n-gons rather than triangles and quads. Make holes. Delete edges and faces that were reused. Useful in cases like bridging to delete faces between the existing mesh and the convex hull. Join triangles. The hull is initially generated using only triangles. This option tries to join them into quads. Has all the same properties as the triangles to quads operator, angle limit, compared with etc. Max face angle, max shape angle, compare. See triangles to quads. Symmetrize. The symmetrize operator is a quick way to make a mesh symmetrical. It does the following. Cut the selected geometry at the origin of this object using an infinite plane, much like bisect. Deletes the geometry on one side of the plane, copies the geometry on the other side of the plane and mirrors it. Merges the vertices that lie on that plane. Mesh before symmetrize, mesh after symmetrize. axis in both direction of the effect and the object's local space, for example. X2 plus deletes the geometry that's to the right of object origin, positive x coordinate, and replaces it by mirrored copy of the geometry on the left, negative x coordinate threshold. The vertices in this range will be snapped to the plane of symmetry. Okay. Fireworks are going off, which is interesting. Gotta love that. I was just thinking about how I could use that to make a fork. Because the first time I tried to make a fork was wacky. Snap to symmetry. The snap to symmetry operator gives a perfect symmetry to a mesh that was only approximately symmetrical before. Unlike symmetrize, which deletes one half of the mesh, then mirrors the other, snap to symmetry matches up pairs of vertices based on their positions, then repositions them. This is useful after, for example, moving a few vertices while accidentally having mesh symmetry disabled. Okay. 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 That makes sense. That makes sense. A little bit of a recover thing. Options, direction, the axis and direction of the effect in the object's local space, for example, negative x2 plus x goes over vertices to the left of the object origin, negative x coordinate, and matches them up with vertices on the right, positive x coordinate. Threshold, the search radius for finding matching vertices. Factor, when set to 1, both vertices in each matching pair receive the position of the vertex on the from side of the direction. When set to 0, both receive the position of the vertex on the to side. Other values result in interpolation. With the value of 0.5, for example, both vertices are moved to their average position. Editing normals. The normals menu can be accessed as a popover by pressing Alt-N. Most of the operators in this menu work with custom split normals, which are normal vectors that belong to face corners, not vertices. Selecting these corners can be done in multiple ways. If the selection mode is set to vertex or edge, selecting a vertex or edge also selects the nearest corners of the face it's part of. If the selection mode is face, selecting a face also selects its corners. If both the vertex and face modes are enabled, selecting a vertex and then adding a face will select just the matching face corner. Similar to the above, if the edge and face modes are enabled, selecting an edge and then adding a face will select just the two matching face corners. The 3D viewport overlay for visualizing normals. Geometry data panel of mesh properties for clearing custom normals. Mesh data transfer operator or modifier for copying normals from another mesh. The normal edit modifier and the weighted normal modifier for recalculating or changing normals based on certain criteria. Flip edit mode. Mesh normals flip changes the orientation of the selected faces, turning their front side into their back side and vice versa. This does not affect custom split normals. The 3D viewport's face orientation overlay is useful for quickly spotting faces that are oriented the wrong way. Recalculate mode. Mesh normals recalculate outside and mesh normals recalculate inside. Shift N and Shift Control N. Flips the orientation of the selected faces where necessary, making them all point outward or inward. The mesh does not need to be closed. Does not need to be a closed volume for this. As with flip, this orientation does not affect custom split normals. Set from face. Sets custom split normals for each selected vertex to the average normal of its surrounding selected faces. Keep sharp edges. When checked, face corners that are part of a sharp edge will keep their original custom normal. Rotate. Shortcut R followed by N. Tool for rotating custom split normals of the selected face corners by moving the mouse. Click left mouse button to confirm or right mouse button to cancel. Point to target. Alt L. Makes the custom split normals of the selected face corners point at a certain target. After clicking the menu item or pressing the keyboard shortcut, choose the target by pressing one of the following keys, also shown in the status bar. M for the mouse cursor, L for the pivot point, zero for the object origin, control left mouse button for the 3D cursor. This also changes the location of the cursor. Cursor right mouse button for a certain vertex, edge, or face. Make sure not to click a space where there's no geometry, as well, as doing so will extrude the selection instead. In addition, the following options are available. Invert, make the normals point away from the target instead. Align, all normals will point the same direction from the average position of selected vertices to the target. Spherize, interpolate between each normal's original and new orientation. The interpolation value can be set in the Adjust Last Operation panel after confirming the operator. Reset R, reset the custom normals to what they are when the operation started. After configuring the normals, press left mouse button or return to confirm. The above options can then still be changed in the Adjust Last Operation panel. Merge. Mesh normals merge. Apply smooth shading to the selected faces and clears the sharp mark for selected edges. Then at each selected vertex selects custom normals that are part of a smooth shaded face to their average orientation. Custom normals are part of a flat shaded face. Custom normals that are part of a flat shaded face are left unchanged. To average the custom normals regardless of face selection, use the average operator. Menu, mesh normal split. Applies flat shading to the selected faces and marks the selected edges as sharp. Then at each selected vertex, sets each custom normal that's part of a flat shaded face to the normal of that face. custom normals that are part of a smoothie are set to the average of the normals of those faces. Average mode, edit mode, mesh normals average. For each selected vertex, divides the connected face corners into groups based on sharp edges. Then sets the custom normals of the face corners in each group to a certain average. The adjust last operation panel has the following options. Type of custom normal face area. Corner angle, like face area, except the weights are determined by the face corner angles. Wait, if the type is set to face area or corner angle, the weight influences which face normals the average normal leans towards. If it's 50, a simple weighted average is used. If it's 100, the average normal is based solely on the faces with the largest area, or corners with the largest angle. If it's 1, the normal is based solely on the faces with the smallest area, or corners with the smallest angle. Threshold. Tolerance value for treating face areas or corner angles as equals. Averaging the custom normals for two vertices. The top vertex has two groups of faces separated by sharp edges, so two separate averages are calculated. The bottom vertex has no sharp edge, so only one average is calculated. The weighted normal modifier is non-destructive. The weighted normal modifier does this non-destructively. Copy vector. Okay. What I'm going to do is find sticky notes. I'll be a moment. A moment. Also drank some cold, refreshing apple juice. So what I'm gonna do is I'm going to write down the section that I am in. Meshes, editing, mesh operators, normals. Copy vector. So that's my bookmark. And I'm going to instead think about browsing a tutorial to do as a practice. You know? Mm. Mm. None of these tutorials look, you know, appetizing to me. What do I even want to make? What even is my goal? What is my thing? What's the thing that I'm trying to do? Shift A, plane. So what's large? Alt S. What's shear again? Shift Control Alt S. Shift Control Alt S. A. Shift Control Alt S. modifier, array, circle, 16, radius, Shift A, circle, Z. Shift G area. I insert E, Control F, base along normals. I don't even know what I'm doing. Physics time. Yes. Now I don't even know how I did the... Now I know... Now I don't know how I did anything. Blender tutorial.
Now I want to try to play this in the
Now it's like...
In this Blender tutorial, I'll show you how to create realistic fire and smoke simulations for beginners. So if you've never used fire and smoke simulations before in Blender, I'll be covering all the basics and going over all the basic settings to create a realistic fire simulation. And if you'd like to help support the channel and purchase the tutorial project files, you can get the project files with the links in the video description. And if you enjoy my videos and you'd like to help support the channel monthly, a great way to do that is joining my Patreon page. So if you join one of my Patreon memberships, you'll get access to lots of Blender content like tutorial project files, and you'll be helping to support the channel monthly. So here I am in a new scene in Blender. I'll have my screencast keys right here in the corner so you can see what buttons I'm pressing. So I'm just going to start by selecting everything, and we're going to delete everything. So when you're doing a fire or smoke simulation, you need to add two different objects. One object is going to be where the fire is emitting out of, and then the other object is a domain which the fire is going to simulate in. So we'll go to the add menu. I'm just going to go here to mesh, and I'm just going to add an icosphere. And then I'm going to scale the icosphere down, and I'll type 0.2, and then I'll press Ctrl A and apply the scale so it's a bit smaller. That's a better size when modeling to the real life scale in Blender. So we're going to have the fire be emitting out of this object. So then we also need to add another domain object where the fire is going to simulate inside that object. So I'll go to the add menu, I'm going to add a cube, and I'm going to hold down the Z button, and I'll go to wireframe view, and in edit mode I'm going to bring the cube up, and then also if I go to the face select and select the top face, I can just bring the top face up. So the fire is only going to simulate in the size of the cube. And generally, it's best to keep the cube as small as you can, because if the cube is really big, the simulation will take longer to simulate because it has a lot more space. So we'll select the icosphere, and then we're going to click right over here to go to the physics properties. Now you can see right here, there isn't any button for fire and smoke, and so we actually need to choose fluid, and then on the fluid type, we'll be able to choose fire instead of liquid. So here on the fluid type, you can click right here, and there's a few different ones here. There's domain, flow, and effector. For this one here, for this object, we want to choose flow because this is where the fire is going to flow out of. And then right here you can see on the flow type, we can choose between liquid or fire and smoke. We'll select the next object now, and we're also going to add the fluid physics. Now this is going to be the domain, so this is where the fire is going to simulate inside the cube. So on the type here, we want to change it to domain, not flow. So choose domain. Now, if you happen to use Blender for video editing like I do, then you might have this playback setting turned on. So if I just open this up, bring this up bigger, you can see on the timeline, if I click on playback, and you can see there is a sync here. Because I do video editing in Blender, I have this set to sync to audio. But when you're doing simulations in Blender, it's a lot better to be able to see every frame. So I just keep this at play every frame. So just make sure it's set to play every frame. So I'm going to press the space bar to play the animation. And you can see there's a little puff of smoke. So there's a few problems with this. For one thing, we can't actually see any fire, we can just see smoke, and then also it isn't continuing to flow. There's basically just one puff of smoke and then it disappears. So first what we're going to do is we're going to select the icosphere and we're going to go here to the flow type. And here on smoke, instead of smoke, we can choose between fire or fire and smoke. Now, if you change it to fire and smoke and then go back to the start and play this, you can see there's a little puff of fire, but then it goes away. And then here on the fire, if I just change it to fire, you can see there is going to be a little bit of smoke, but there's a lot less. So if you want to have more like smoldering flames, and if you want there to be a lot more smoke, you can choose fire and smoke. However, I just want a little bit of smoke because I mostly just want it to be fire, so I'm going to choose fire. So choose fire and smoke if you want a lot more smoke, or just choose fire if you want very little smoke. Now if you pause the animation and then try going into the rendered view or try rendering this, you can see the fire isn't actually there, and that's because this fire here and the smoke that you can see is just a preview in the viewport. So later in the video we're going to be setting up a material for the fire, but just for now that is just going to be a preview in the viewport. It's normal that you can't see any fire in the render. Now I want there to be continuous fire, sort of like if this were a fire pit. So to fix this, we're going to go to this flow behavior. Now on default, it's set to geometry, and so the geometry is just going to create fire depending on the object's geometry. So for example, if I have like a really big icosphere, there's going to be a big flame which is coming up, but it's only going to make as much fire as the size of the geometry. So because I want continuous fire, we're going to click on the flow behavior, and we're going to change it to inflow instead. This way, if I play the animation here by hitting the spacebar on the timeline, you can see there's just continuous fire. So now it looks like fire flowing from an outside campfire. Now there was also another one here which was called outflow. So if I duplicate the icosphere and bring it up here, and then on the flow behavior, I'm going to change this to outflow. This is going to remove fire which touches it. So I'm just going to scale this up, stick it right here. Now if I go back to the starting and play this, you can see fire is going to disappear when it hits that object. So if you want the fire to disappear, you can add another object and change it to outflow, but I'm just going to delete this object. Now you can see that sometimes the simulation will update. You can kind of see the fire still disappeared. So you can go back to the starting and then play it again, and that might fix it. Another thing you can do is just slightly move the object, kind of drag the object over, and then if you play it again, that should fix the simulation there in the viewport. Now I wanted to show you how to set up the fire manually. However, there is a way to create a quick smoke effect. So if I just go to the add menu and add another icosphere, I'll just scale this down and bring it over here. With this object selected, I can click on object and I can go here to quick effects, and there's a few different quick effects here like fur, explode, and a few different more ones. I'm going to choose the quick smoke. And so what this is going to do is going to create a domain, and it's going to add this object and then add smoke coming out of it. So this is a much quicker way to quickly set up a fire simulation. So it's pretty much done everything that we've done here in this simulation. So if you want to just do that in the future, you can just add an object, and then you can just go to object, quick effects, and you can add quick smoke. So now let's go over the different settings to change the look of the fire. So we're going to select the icosphere again. So we already talked about the flow type, so you can choose between smoke, fire, or fire and smoke. I'm going to leave it at fire. And then we already talked about the flow behavior, so inflow, outflow, and geometry, but for this object we're going to use outflow, so it flows out fire. Now there's also this check mark here called use flow. So if I turn this off, go back to the starting and play this, you can see there is no fire, or if I turn it back on, you can see the fire is going to start. So this is great for if you want to have like the fire be delayed. So let's say you didn't want the fire to start until frame 60. So what I could do is go one frame back, I can turn this off, and then what I can do is hit the I key with my mouse hovered over that value. It's going to add a keyframe. Then if I go one frame over by hitting the arrow key, I can click to turn it on and then hit the I key to add another keyframe. You can now see there's 2 keyframes in the timeline. So if I play this, that's going to delay the animation. So now if I play this, the fire starts. And then what I could do is hit the I key, go one frame over, turn it off, and then hit the I key again. So now you can see it starts at frame 60, and then you can see it'll just start and the fire will just go out. So this is a great way to animate the fire. But I'm just going to select the keyframes and just delete the keyframes, and I'll turn the use flow back on. So you can use the use flow just to animate the fire turning on and off. Now, the sampling sub-steps is going to improve the quality of the fire. However, if you turn this up too high, it might start to get kind of laggy. You can see it doesn't look too bad, but it is definitely a bit more laggy. However, I'm just going to keep this down to 0. I don't really want to turn up this value, but if you find it's a bit low quality and you want to improve it, you can turn that up. Now, as far as the general quality and the detail of the smoke, we're going to be adding a lot more detail later. You can see it's really blobby right now, so we'll be adding that later. We'll be adding more detail to it later in the video. Now, there's also this absolute density, so if I turn this off and then play this, you can see more and more smoke is just going to continue to build up. So this makes like a really large fire simulation. This might be good for like an explosion or like a large house that's on fire or something. But if you turn the absolute density on and then play this, you can see it's going to be more natural, looks more like a campfire. And so the smoke is going to dissipate and then go away, and then more smoke will replace it. Now the fuel is going to fuel the fire. So if you turn this up, there's going to be a lot more flames. So you can see if I turn this up all the way to 5 on the fuel, there's going to be a very large simulation. Or if I turn this down maybe to like a 0.2 and then go back to the starting and play this, it's going to be a very small simulation. What I'm going to do is turn this to like a 0.6. So now when I go back to the starting and play this, you can see the simulation is just a little bit smaller, and I like that a bit better. So the fuel is going to add more fuel to the fire. So it's like you're adding more logs to the fire and making a much larger fire. Now there's also this vertex group here, and so you can create a vertex group on an object, and then the fire is only going to come out of that area. So let me just go into edit mode, and what I'm going to do is go to the face select, and I'm just going to select these two faces. I'm now going to click right over here to go to the object data properties, and I'm going to open up the vertex groups. I'll click on the plus here to create a new group. You can rename the group if you want to, but then I'm going to click on the assign button, and that's just going to assign those faces to that vertex group. Now what I'm going to do is go back here to the physics settings, and here on the vertex group, I can choose the group that we added. And now when I play this, you can see it's just coming out on this corner because it's only emitting out of those faces. But I'm just going to delete this because I want it to come out the entire thing. But if you have maybe like a ground plane or some kind of object and you just want to have the flames coming out of little bits, like maybe you have a log which is on fire, you can just assign the vertex group to different parts of the log or the object. And then the fire will only come out from those faces. Now there's also the flow source here, so I'll open this up, and there's two main settings. There is a mesh and there's particle system. So with mesh, it's just going to emit the flames out of the object's mesh. However, if I change this to particle system, it's going to be emitted out of the particles. And so let me just show you real quick. You don't have to follow along with this, but you can if you want to. I'm going to go to the particles here. I'm going to click on new to add new particle settings. And then if I play this, you can see particles are coming out, and I'm just going to bring this up here so the particles kind of fall down into the domain. And then what I want to do is go back to the physics, and here on the flow source, we set this to particle system, and then we can just choose the particle system that we added. Now, if I play this, you can see that there's going to be fire coming out of the particles. So let me just scale up the domain object, make it really big. So now you can see it's like almost like there's a bunch of little fireballs or something which are coming out there because every single one of the particles is going to be emitting fire. So you could definitely get some really cool effects with this, especially if you turn up the quality. It looks kind of blobby right now, but if you turn up the quality, it could look really cool. But what I'm going to do is just select this object, and I'm going to delete the particle system. Let's just bring this down here, go back to the starting, and I'm going to bring the domain here back to the original size and just bring this down here. So we're just back to where we started before. And if we select the icosphere, go here to the flow source, I'm going to change this back to mesh. So the fire is just emitted out of the mesh of the object. Now there's another cool option here called initial velocity. So I can turn on the initial velocity, and we can basically make the fire shoot out in one direction. So for example, there is the normal. So if I turn up the normal, let's just turn this up to like a 1. I need to make it a little bit stronger. So I'll turn this up to like a 20, and I'll bring the icosphere up here. So now when I play this, you can see the fire is coming out of the direction of the normals. So the normals are the
I think I should be doing simulation. Not on this hot of a day. Honestly, I think I'm cooked. I don't know what I'm doing now. Hmm. My brain is too cooked to keep going, I think. I wish I could keep going. Yeah, I'm gonna need to stop. I'll uh I'll read the manual more tomorrow before I have to go to work. I'll see everybody later. Goodbye.